All right, picking up where we left off, remember that we said that the pH of most living cells must remain close to pH of 7. So how do our cells achieve that? How do we protect ourselves? And one of the ways we do this is by utilizing things called buffers. So buffers are things that minimize changes in concentrations of hydrogen ions or hydroxide ions in solution. Most of these buffers are essentially weak acids and its corresponding base. Okay, so if you take a weak acid and you break it apart into its hydrogen ion and its negatively charged ion, that negatively charged ion can suck back up a hydrogen ion. So these weak acids and act in our cells to protect us from becoming too acidic, and it can also protect us from becoming too basic. These buffers can also be used artificially in chemistry when we want to create a solution that has a particular pH. And each particular weak acid or weak base has a pH where it forms an equilibrium between ionized and not ionized forms. So just by picking the correct weak acid, we can make a solution at any pH we would like. All right, so how does this affect us in the world? And I had referred to before that seawater tended to be slightly acidic. Well, this actually comes from us, okay? And not only us. All living things, as we consume food, all animals, that is, as we consume food, give off CO2 as a waste product, okay? Now, we as humans release huge amounts of CO2 by burning fossil fuels, okay? So what happens to the CO2? Well, most of it, or not most of it, but a lot of it gets absorbed into the oceans. Now, what happens when it gets absorbed? Well, when CO2 comes into contact with water, it actually forms a new compound, and this new compound is called carbonic acid. Carbonic acid, as its name suggests, is an acid, so it can ionize, producing a hydrogen ion and its conjugate base. Remember, I said that the conjugate base has a negative charge and is what's left over. Now, this could reabsorb that proton, or it could leave it free. And there's a pH, which is in the acidic range, where this forms an equilibrium. So we are starting to get the ocean slightly acidic. So that explains why seawater is slightly acidic. This is an additional problem because there are creatures in coral reefs, the coral themselves, that build hard exterior shells by taking a carbonate ion, combining it with calcium to produce calcium carbonate. Okay? This is a solid material in water, and they can build protective shells out of it. This is actually the exact same thing we do to strengthen our bones. We actually take carbonate ions, combine it with calcium, and produce calcium carbonate, which is why we need calcium for strong bones. Now, how does this combine with acidified seawater? Well, what can happen here is, since we have acidified seawater and we have this reaction taking place, the carbonate ion, instead of combining with calcium, can combine with the hydrogen ion and produce something called bicarbonate. Okay? This here is a preferred reaction to this here. So as we acidify the oceans more and more and more, we actually prevent this process from forming. And that is going to have a long-term effect on the oceans. So, concept 3.3, acid and basic conditions affect living organisms. So remember, hydrogen or waters form hydrogen bonds. Every once in a while, that proton in the hydrogen, or that hydrogen ion, or that hydrogen in the hydrogen bond can leave, forming a hydronium ion and a hydroxide ion. This here has a positive charge, this has a negative charge. Sometimes we refer to this solely by the extra proton, so H positive. The pH scale is defined by the concentration of these positive ions, so negative log of the molar concentration. This produces a pH scale that we can see all these various different things on. Adding certain solutes called acids and bases can modify the concentration of H and OH. So these things that called acids release hydrogen ions, making the pH go down, and bases release OH, which consume H, forming water, and that causes the pH to drop, or to, not drop, but to increase, moving towards 14. And this can have a global effect in that it can both affect our cells directly, or in the long term, that carbon dioxide can move into the oceans, acidifying the oceans, and that can stop the process of reef building.